Hello everyone, welcome back to my channel Indian CVs. So today this is the part 1 electrical, which is for the MEO class 2 people also, and this is also for the electrical people, electrical engineer-Etos also. So today in the first part I will deal with these 10 questions. Basically these 10 questions I will deal today, and this 10 question is selective catalytic reduction system, exhaust gas cleaning system, and if two generator running in parallel showing different kilowatt, why, what are the reasons, I will show you everything. And after that, electromagnetic fail-safe circuit and Zener diode and its application, eddy current, and flame resistant, flame retardant, and Armoured cable, and the preparation of the electrical survey in detail. What are the electrical surveys preparation we are doing generally in these vessels, and Solas regulation of the AVR, and normal transformer versus welding transformer. So today these are the most 10 important questions, and after that this part by part I will deal with the another 10 questions. So each and everybody just continue in my video and you will get more and more video like this. So these are the most important questions generally asked in the all MMDs in India. Whichever MMD you are going, they will ask this type of question, and this is the only questions asked by the surveyor. This is not my own question, this is asked by the surveyors. So let's start the video, don't waste the time, otherwise video will be so long. So let's start the video. Hello, so let's start the first question, that is the selective catalytic reduction system and why we are using this in the vessel, the main purpose of this, and what we are doing in the selective catalytic system. So let's talk about this. This is the oral question. So our ship having the main engine and boilers that eject the exhaust gases, which is the very dangerous for our environment, and which increase the greenhouse effect in our environment. So what are the gases generally? That is the CO2, carbon monoxide, carbon dioxide, and the SOx, NOx. So these are the basically harmful gases which is very dangerous for our environment, and we have to reduce the greenhouse effect by 2050 by the net zero. This is the policy of the aim target of the IMO also, which I deal in the safety part also. So we have to reduce this emissions because this is very dangerous for environment, which increase the chances, which increase the percentage of the greenhouse effect in our environment. So what we are doing with this selective catalytic reduction, we remove this NOx. You see this NOx which is producing. So we are reduce the effect of the NOx, and when we exhaust the gases to the environment, this is not that much dangerous because already we neutralize this NOx into the harmless products. So how we can do this? This NOx is very dangerous for our environment. So we do nothing here. We take the one selective catalytic reduction system. This is the selective catalytic reduction, and we inject the exhaust gas, which is the harmful gases, exhaust gas, that is let's suppose as NOx. We inject the harmful gases, and in the SER system we treat with the aqueous urea. Aqueous urea, aqueous urea with a special catalyst. Okay, so we take this aqueous urea and special catalyst and fed into the SER system. After that a chemical reaction happened, and this chemical reaction happened onto this, that convert this NOx into the harmless product. What they convert? They convert the NOx into the harmless products. So I remove this one. Just for the understanding, if you understand it very well. So here you can read also. I will mark this point special. SCR is the active emission control system. Hot gases, exhaust gas. This is not good. Let's take this one. SCR is the active emission control system. Hot gases flow out of the engine and is spread into the SCR system, where aqueous urea is spread into the special catalyst. So I already told you, we take the aqueous urea and a special catalyst, and after that we fed the exhaust gases NOx onto the system, and that sets up a chemical reaction in the exhaust on a special catalyst that convert nitrogen oxide into the nitrogen and water and tiny amounts of carbon dioxide. So the amount of the CO2 is now very reduced. CO2 is very reduced in very tiny amounts. Okay. So amount of the NOx is also reduced, and it convert into the nitrogen and water. And you know, nitrogen is nitrogen in our environment. Nitrogen, the percentage of nitrogen is also very high, so that is not a problem. So water already this is not also harmful. Now only the tiny amount of the carbon dioxide, that is basically a little bit dangerous for our environment. So how we can do this? So we reduce this NOx by the help of the aqueous urea, okay, aqueous urea plus catalyst. So these are the basically compound we are taking in the SCR system to reduce the effect of the NOx. So these are the selective catalytic reduction system that is asked by the most of the surveyor in the oral examination. That let's start the second question, because otherwise video will be so long and you people will think it's very long video, how I can read and write like this. Okay, so further let's start the second video, exhaust gas cleaning system. What is exhaust gas cleaning system? Here exhaust gas cleaning system basically known as scrubbers. Now the vessels are fitted with the scrubber. In the most of the big vessels they fitted the scrubber system to reduce the effects of SOx. SOx is also, I already told you, the SOx is also very dangerous for environment, as I discussed before also. This carbon monoxide, carbon dioxide, SOx, NOx, this is also the harmful products for our environment. So previously I see the NOx, now I talk about the SOx, how we can reduce the SOx. So SOx are basically reduced by this exhaust gas cleaning system, that is a scrubber system. And basically two type of scrubber system is there: open loop system and closed loop system. If I talk very fast, so you people just comment, sir, please talk little bit slowly, so you can guys mostly understand very well. So because I have to complete this 10 question, so I am just talking very fast little bit, but I will clear your concept very much. You don't have to read so many things, and after that if you go through this lecture you can easily understand everything. So let's start. Exhaust gas cleaning system is basically referred as scrubber system also, and device installed on board marine vessel that literally scrubs out harmful sulfur oxides from the exhaust gases. So what is the SOx? SOx is the sulfur oxide. Okay, SOx is the sulfur oxide. So in this scrubber system we reduce the harmful sulfur oxide into the harmless product, and after that we eject to the environment. We just exhaust into the environment, so it is not that much harmful. And how we can reduce this SOx effect? There are the various ways we can reduce the SOx effect. I will deal in the Annex 6 of the MARPOL, that is for the safety part. So I will just give a little bit overview how we can reduce this sulfur dioxide. The first main purpose, you can limit the limit sulfur content, because we use basically gas oil, diesel oil, so the sulfur content is very less. And according to the IMO also MARPOL regulation is there, we use 0.5% of sulfur. Okay, and for emission control areas we are using basically 0.10% sulfur content. Okay, so this is also, you know, in Annex 6 I will deal in the safety part. And after that we can use this scrubber system to also to reduce this SOx effect. So these are the various ways which we can reduce. I can deal in further later section. So basically first I deal with this scrubber system. What is the scrubber system? So scrubber system sprays seawater or fresh water mixed with the caustic chemical in the exhaust gas stream in the several stages. So here what we are doing, we are taking this exhaust gas cleaning system where we use ECGS, okay, where we are taking this seawater or fresh water. Okay, you see, seawater and fresh water plus caustic soda. Okay, so we are taking these chemicals. We use the seawater, and you know there is too much seawater in the sea, so don't worry about the seawater. And fresh water we are taking also sometimes. Okay, so we take the seawater and fresh water mixed with the caustic chemical into the exhaust gas stream in the several stages, and the pollutant, mainly sulfur dioxide, reacts with the alkaline water. So what's going on further? So the pollutants, mainly sulfur dioxide, now reacts with the alkaline water. You know this sea water, fresh water are alkaline in nature. If there is no alkalinity, we can increase the alkalinity by the help of the caustic soda and all this. We are increasing this alkalinity of the water. So what there happened after that? So this sulfur dioxide can react with the alkaline water to form a sulfuric acid. You know this sulfuric acid, but this is not a big much amount, this is little bit reduced amount. So in the case of open loop system, the resulting wash water is discharged back into the sea. So in the case of the open loop system, the resulting wash water is discharged back into the sea. There are the two type of system in scrubber. One is the open loop system and another one is a closed loop system. So first let deal with the open loop system. What is the open loop system? Okay. So open loop system uses a seawater which is alkaline by nature to wash the SOx out of the exhaust. The resulting discharge must meet MARPOL requirement before being discharged. So what we are doing in the open loop system? We take the open loop system. Okay, we take the open loop system, open loop. Whatever the point I mark, na, that is also important for the oral. You can talk this in front of the surveyor also. They are highly impressed. So open loop system. So what we are doing here? So open loop system we take, and after that this exhaust gas SOx. We use here seawater. Basically we pump through the help of seawater, various seawater. Okay, and after that it convert the SOx into a harmless product, SOx harmless, and then we discharge into the sea, okay. So discharge into the sea, and but need the MARPOL requirements. Whatever the MARPOL requirements, I will tell you in the safety part. Whatever the MARPOL requirement, how you can discharge, because we are not discharge anything directly onto the sea. There are some requirements and there are some rules and regulation which is basically implemented by the MARPOL. So basically after that if the requirement is meeting the rules and regulations, then we can discharge onto the sea easily. Okay, so this is the open loop system of the scrubber. And closed loop system, what we are doing, we are nothing, this is also same, but we are doing just a little bit change. In the closed loop system, a chemical such as caustic soda to the wash water, okay, to boost its alkalinity. What we are doing, we use the caustic soda. The surveyor, you can also most of the time surveyor will ask, okay, why you are using the caustic soda? So caustic soda, the main purpose of the caustic soda is to boost the alkalinity of the water, so it can convert into the harmless product easily. And after that, what we are doing in the closed loop system, we add the chemicals such as caustic soda with the seawater or maybe fresh water also. So after that, it boosts the alkalinity, and the wash water is then recirculated through the system and partially purged. मतलब it means कि हम लोग यहाँ पे एक closed loop system लेते हैं. This is the closed loop system, okay, closed loop system, and we add this caustic soda, seawater or fresh water, and after that here this SOx, and after that we recirculate this also. Again, if the content of the harmless product is not under the limit, we can recirculate onto the input also. We again feed into the closed loop system, and some part is partially purged, okay. And here is the feedback. We are taking this feedback. Why we are taking this feedback? Because the Marpole requirement, we have to follow the Marpole requirement. Until and unless the requirement and rules and regulation are not followed, we are not able to discharge onto the sea or somewhere. So what we are doing, if not meet the requirement, we can recirculate this into the system again, and after that it will go into further treatment, and again it will come, and if the again requirement is not met, it will again recirculate like this. So this is the closed loop system. Basically we are doing in the closed loop system of the scrubber, and this is the basically two system. Selective catalytic reduction system, which is for this NOx, and exhaust gas cleaning system, which is basically for the SOx, nitrogen oxide and sulfur oxide. So basically these two questions I already deal. So now let's go further to this number 3 questions. Okay. So if you have any doubt in the further 2 questions, you can ping in the comment section. Okay, sir, I don't understand this point and all, I will explain everything better. So no problem, let's go for further questions. So this question I will talk you about this, but I need some page here for your understand. Okay, I take one page. If what are the question you see here? The question is, question is, if two generator running in parallel showing different kilowatt, okay, why? So two generator if running in a parallel in different kilowatt, so kilowatt, you know, this is the actual power, and reactive power, and you know this, there are the various type of powers. So kilowatt is the basically the active power, reactive power, and basically apparent power, basically 3 types of the power. So if you want to understand how this changes is happen, you have to first understand this active power, reactive power. After that you can understand it very easily. So I will just brief you, just simple, within 1 or 2 minutes I can just explain little bit. So this one side denoted by active power, and this is a bigger topic, but I will just explain little bit so you can understand it very easily. Active power, and this R denoted, this is denoted by R. Reactive power is Q, also denoted by sometime by Q. Okay, R or Q. Reactive power. Okay, and this is the apparent power, which is a vector sum of this apparent power, vector sum of, okay, apparent sum of this active power and reactive power. Okay, vector sum, apparent power. So you know this angle basically denoted by phi, that is the basically this phi is nothing but power factor. Okay, this is the power factor. If this angle is more and more, the power factor is poor. So if phi is more, the power factor is bad. Okay, and if phi is less, it means the angle phi. So if the angle, this angle, so this angle, you know, this angle if less, then power factor is good. It means they are not consuming that much reactive power for support the active power. So I will tell you what is the active power. Active power is which active power, I will denote with the only alphabets. Okay, the active power is do the useful work. Okay, basically what the power the machinery is taking, that is the active power, and the reactive power is nothing, is not useful, but because it's not useful, it means it's not useful, but it support magnetic field throughout the circuit. Because you understand like motor, if there is motor, okay, this is motor, and if you give this supply 3 plus supply, so if you give this supply, it will create a rotating magnetic field, and this rotating magnetic field when cuts with the rotor bar, then again one secondary magnetic field produced, and after that when they interact with each other, then there is a force developed which convert this into a rotational motion, that is the torque. Then the motor is start rotating. So this magnetic field, which is very important in this, if without this magnetic field, our motor will not turn. Our motor will, without magnetic field, our motor will not turn or rotate. So this magnetic field is very so magnetic field B is denoted by B is very important. So without the B, it will not support any rotation or further movement. So Q, now you can understand it basically. It is not useful, but this supports the active power and magnetic power. Also support active power. Active power. So now you can understand what is the reactive power and what is the active power. If this angle is more and more, our this reactive power is taking more. It means the machinery is taking the reactive power is more. If phi is high, then this reactive power is also high. So our for doing, if let's suppose there are the two motors which having the same capacity, this two motor which having the same capacity, motor 1 and motor 2 having the same capacity, but if this power factor, let's suppose cos phi is 0.8 and this cos phi is 0.6, so what here Q is good. It means they are taking very less reactive power, very less reactive power to support active power, So our motor will start rotate, and after that it will take very less current, take less current also, take less current. So it take very less current, take less current to do the job. Same motor, same capacity, okay, same capacity. So here this two motor which is the number 1, number 2, they are taking the less capacity, and this motor having the less power factor, it will take the high current to do the same job, okay. So this motor having the two capacity, so now you can understand it better. This two motor having difference in the power factor, this motor is taking the high current for do the same job, and this motor is taking the less current for doing the same job. So now you can understand it very also well. This reactive power, why is important? Reactive power basically just support this active power to do the job, and this this apparent power, which is the vector sum of this active power and reactive power. So now you can basically understand this very well, and I will tell you also this important. First I will remove this all, okay, wait, I can remove this all. So now you can understand very well more. I hope you understand this concept very well. So let's suppose, let's go here again this questions. Now I come to this questions. Okay. So how this, now you understand why different kilowatt and all this, now you can understand very well. The first concept is the load sharing. First, you can tell the load sharing. Load sharing generator may not sharing the load equally due to difference in their capacity or the setting. In the generator capacity, so can the kilowatt difference is there. The first you can understand this. There is, because this power different, capacity is different. So it can maybe this one reason to taking the different kilowatt. So here different kilowatt. The first is the load sharing, and second is the voltage and frequency difference. Second is the voltage and the frequency difference. If the voltage or frequency of the generator is not synchronized, then may not operate efficiently, leading to the unequal load distribution. So you can understand this very easily now. Second concept is this active power. Okay, active power is equal to P is equal to root 3 Vi cos phi. So you know this power here depend on voltage, current and power factor. Basically any of these things is up and down, so power will be vary. So you can tell this also ki by voltage, difference in voltage, power factor, our power consumption will change. So active power will change. Now you can understand it very well. By if the voltage or the frequency of the generator is not synchronized, if let's suppose the voltage one generator having the voltage, generator 1 having the voltage 438 volt and this generator 2 having the voltage 442 volt generally. So there is a voltage difference. Due to this voltage difference also the power requirement is also different. So our kilowatt is also different, because power is directly dependent on the voltage and current. So if you are paralleling this these two generator, the voltage must be same. Voltage must be same. If voltage any difference in the voltage, it will difference in the our active power. So active power, that is the kilowatt. Okay, this is the kilowatt active power. So this, if any of the voltages changes, this active power is changes. So this is also one reason. And this power factor also one reason. You can tell this power factor. So what we have to do, we have to adjust this power factor also. That is we are doing with the droop setting. And here also in the second point written, it depends upon this speed also. So droop setting basically is nothing. Droop setting, when the load on the generator increases, let's suppose load increases on the generator, our frequency of generator decreases. So droop is nothing. Basically when the load is increasing, the frequency of the generator is decreasing and the fuel consumption will increase. So this is the droop setting basically. Okay, so droop setting now is the frequency, how the frequencies changes. Ns is equal to 120 F by P. You can see here this is Ns is equal to 120 F by P, where F is the frequency, P is the number of pole, and Ns is the synchronous speed. Okay, this is a synchronous speed. So you see here, if the load is increasing on the generator because of the power difference, the load is increasing or decreasing, and due to this load increasing or decreasing, the frequency is also change. Frequency will decrease because there is a reactive power, more reactive power. Then when the load is increasing, then there is a demand of reactive power is more, and this due to the reactive power is more, there is a drop in the frequency, and which drop in the speed also. Okay, speed also decrease. So it depend upon what? Voltage, speed depend upon which? Frequency. Okay, so basically these two component also vary this our kilowatt difference. So voltage and frequency also matter here. Okay, so you can tell this also. Let understand the concept, because you can now directly tell sir, this voltage and frequency depend this voltage and frequency, due to the voltage and frequency difference, our generator kilowatt different. But when they ask you certain question, you have to explain it everything very in in a deep concept, because they can understand the concept also. Because you don't know the concept, you just memorize this voltage and frequency, this voltage and frequency, you will confuse also. So basically clear your concept. After that you don't have to read anywhere, you can understand it everything very easily. So governor setting also I already told you, the droop, which is the governor setting. So what we are doing for this kilowatt adjustment, basically governor is increasing or decreasing the fuel consumption. Governor is increasing or decreasing the fuel consumption. So I will just remove this all, I will tell you the governor. So load governor, load increase, frequency decrease, speed also decrease, and speed also decrease. Okay, so we fuel consumption have to increase to balance load. Okay, and after that if load decrease, frequency increase, speed also increase, but this is also dangerous. So what we are doing here, fuel consumption need to decrease to balance load. Okay, so fuel consumption has to decrease. So how we are doing this all, how we are doing this all, we do with the help of the governor. Okay, so everything depend upon the governor. We adjust the governor droop setting inside. You see the governor, there is a droop setting, you have to adjust the droop setting to maintain the same load, so maintain the same kilowatt. So what we are doing this governor droop setting changes, and after that everything will be fine. So these are the basically important points I already discussed. Okay, so this is the questions. I think this video will go a little bit longer, so I will divide maybe in the 5 questions part, so you can people understand more easily. So already I told you, first is the load sharing, second is the voltage or frequency, and third is the your governor setting. Okay, if somebody, let's suppose, change the setting also by mistake, there is also variation in our load, and due to this our kilowatt also changes. So basically these are the points you can tell easily very to the surveyor. So I think you can understand it very easily. Now I will remove everything. Hope so you guys understand it very well. Okay, so now everything is okay. So you already understand everything perfect. And here this last one is the power factor. I already informed you because the power that is dependent upon the VI cos phi for single phase, and for 3 phase is √3 multiplied. So cos phi, voltage, frequency, everything is dependent, power is dependent, everything on voltage, power factor also. So you can tell also power factor, voltage, frequency, load sharing. So these are the conditions for this showing variation in the kilowatt. So you guys understand it very well. Now move to the next question. Zener diode application in the SIPs. So what is the Zener diode? I will tell you. Basically Zener diode is a diode, come to this section. Zener diode is a type of diode that permits current not only the forward direction like a normal diode, but also in the reverse direction if the voltage is larger than the breakdown voltage. Okay, so you know the diode, what the diode is and what is the Zener diode. Diode is a circuit like diode. This is the symbol for the diode. Okay, this is the anode and this is the cathode. And diode basically, when we combine these two type of semiconductor, p type and n type, and after that it will make one diode. And when we give supply like this, positive battery connect with the positive supply, and this is the positive side, this is the negative side, positive with the positive and negative with the negative, then there is a current flow in this direction from anode to cathode there is a current flow. Okay, so it will help in the flow of current. It can control the flow of current, and it can convert the AC signal into DC signal. With the help of diode you can convert the AC into DC. So various application of the diode, and same as Zener. But what happen when in the normal diode, now when we in the normal diode wait, in the normal diode, like this normal diode, when we connect in reverse bias, what in the reverse bias, this is the reverse bias, negative positive, and this is the positive negative. Now you can understand it very well. This is the positive side of the diode, and I connect with the negative terminal of the battery, and this is the negative side of the diode. It is basically negative is shown by this. You see, this is the negative. This by silver band is there on the diode. When you see the diode, now there is a silver band onto the diode. Okay, so this is the negative terminal. I connect with the positive terminal of battery. So there will be no current flow. There will be no current flow because of the depletion width. I will talk about in the later section about the diode, how the diode is working. You just understand a little bit concept, so you can clear after that Zener diode. So when we connect this diode onto the negative terminal, and this negative terminal to positive terminal, reverse biasing is called reverse biasing. No current flow. Okay, so this is the behavior of the normal diode. Okay, this is the behavior of the normal diode. But in the Zener diode, what will happen? It can operate in the both direction. Even if you give this forward, even if you do this forward biasing and reverse biasing, current flow is there in both direction. It can forward biasing also, current is there, current, and reverse biasing also, current will be there. But in reverse biasing, if the voltage is increased above this breakdown voltage, because there is some breakdown voltage of the Zener diode, if the voltage is larger than, that is denoted by the Vz, if the voltage is larger than this breakdown voltage, and also known as Zener knee voltage, that time it will start conducting in the reverse direction also. So why we are using this, the main purpose of this, now you can understand the Zener diode is a type of diode which can conduct in the both direction, in the forward direction, in the reverse direction also. And this is the only diode which can conduct in the both side, and the other diode can only conduct in the one side. So this is the Zener diode, and the main purpose of this Zener diode, I can tell, basically we are using this Zener diode in the flammable area, where there is a flammable areas in the shape, like the tanks and hazardous area, cargo holds. There are the various areas in the vessels, that is the hazardous area, because of the flammable gases are present inside them. So we can limit the current and voltage there with the help of this Zener diode, because it can operate in the reverse bias also. Because the voltage will increase, it can pass the current through them, and it can protect the another circuit also. Okay, it can protect the environment from any hazard or from any explosions also. The main purpose of this, for an explosion we are using this, and also we can use this for the voltage generator also, voltage regulator also. Okay, little bit mistake. Okay, so now you can understand very easily. For an explosion, all the three gas, dust, oxygen and source of ignition, spark or heat needed to be present. एक्सप्लोजन के लिए क्या क्या चाहिए हम लोगों को? बेसिकली गैस प्रेजेंट होना चाहिए, सोर्स ऑफ इग्निशन शुड बी देयर, and heat, some heat should be there. Okay, some spark or heat should be there. If the, you know, this fire triangle, okay, fuel, oxygen and heat, basically these three triangle create fire. Okay, if you can remove any these three things, any one of these three things, it will not create a fire. So basically what we are, for explosion we need gas, oxygen and spark or heat. So what we are doing is, with the help of this Zener diode, we can remove this heat or spark. We can limit this current, because if voltage will not increase, our current will not increase, there will no spark. no heat will be there. So no heat will be there, so there will be no fire. So with the help of the Zener diode, we can protect our vessels from any explosion, from any hazard or anything that is very dangerous for our vessels. So we are using this Zener diode. The main concept is this, is basically we are using in the explosion areas, hazardous areas. Okay, so intrinsic safety works on the principle of removing the source of ignition. This can achieved by using a Zener barrier or galvanic isolator. We are using a Zener barrier and a galvanic isolator to limit the current, to limit the voltage and limit stored electrical energies. Okay, so what we are doing, we limit this current, voltage and limit the stored electrical energy. Like in the capacitor there is a stored energy is there, so we can limit this also by using the very we are using in the hazardous area very few microfarads capacitor, or we are using millihenries inductors we are using in the hazardous area. We are not using the big microfarads and Henry inductors should be there, because they can store more energy and they can cause ignition there. So we can limit these things to reduce the effect of ignition. So Zener barrier is a simple device where the voltage and current is limited into the hazardous area. Okay, so what we are doing, we can limit this voltage and current. And how we can do like this, this is the Zener diode circuit. You can see here, it can here you see output hazardous area, here you see device hazardous area. This is the hazardous area, and Zener safe barrier, it means there is a circuit inside this Zener barrier, this safety barrier circuit is there, and galvanic isolator all are fitted into this. A small component is there, and it can fitted in the safe area and this input in the hazardous area. Okay, so it can sense the voltage and current in the hazardous area, and if there is any increase in the current and voltage, it can pass through the Zener barrier and it can directly to the ground. So it can protect the further ignition or spark from there, and it can protect the environment also. Here is the Zener barrier, which is the Zener diode. If the voltage is let's suppose if the current is more in any circuit, let's suppose inside the hazardous area there is a sudden spark is there. So if the current is increased, it can limited by this resistor. Resistor can limit the current, and voltage can be limited by this Zener diodes, and there is a fuse protection should be there. Fuse protect the Zener diode from the becoming overstressed. If there is a more suddenly large voltage surge or current surge is there, so the fuse is also provided for protection circuit. Okay, so these are the basically Zener diode. The voltage is limited by a Zener diode and the current is limited by an resistor. I already told the voltage is limited by a Zener diode and the current is limited by the output resistor, and fuse is there to protect the Zener diode. Fuse is basically to protect the Zener diode, because if the Zener diode will collapse, if Zener diode will damage, it cannot support the protection for the hazardous area, and there can maybe the chances of the explosion or any hazard should be there. So we have to protect the Zener diode also. If the voltage is that much of limit, Zener diode is also not able to support that voltage, so then in that case there is a fuse protection should be there, and this fuse will protect this Zener diode and our circuit will be safe, and it can trigger the alarm, so the person can also know ki ha, there is something happen, we have to check this one, and after that we can rectify the problem. The key to safety is the intrinsic safe earth, so it can directly do the grounding. Okay, so basically there are three type of zone is there, and it can why you see here 3 diodes, 2 diode, 1 diode is there. So depend upon the zone is there on the vessel. There is a zone 1, zone 2 and zone 3. Zone 0, zone 1 and zone 2 is there. Okay, so zone 0 is very dangerous area where always the flammable gas is present, and zone 1 is a moderate level of flammable gas, sometime happen, sometime not happen, but there is a chances of the flammable gas, and zone 2 is there is a very less chance of the flammable gas present. So based upon that we are using the Zener circuits, and we increase this Zener diode in parallel, and increase the resistors also in the series. So you see here in this circuit, in zone 0 we are using the various Zener diode. It means the Zener diode, number of the Zener diode will increase. We are doing the duplicacy of the single circuit of this Zener diode, and we can connect them in like this way. This is the one part and this is the second part, and based upon that we can combine this in, and we are using in this hazardous area. So it can further protect from the double fault protection like this. In EXI is the double fault protection. It means even one diode will fail, another diode is there to protect the circuit, okay, and protect the environment also from the hazardous and flammable environment. So we are using the duplicacy of the Zener diode and resistor to give the further protection, okay. That is for the double protection and single protection. So EXI is the double protection with safe with the two fault. Even two fault will occur, it can survive, but after that it will not survive. Even two fault, let's suppose one fault and another one fault. So this is the Zener diode. I already explained everything I can explain here. So now I hope you understand the Zener diode very well. So I will go further to the next question. Okay. What is the Zener diode? I already told. Okay. The sixth question is what is eddy current? I will not go in that much detail. I will just tell you little bit what is eddy current. Eddy current are the current that circulate in the closed loop within the conductor when a magnetic field changes or a conductor moves through a magnetic field. When there is anything change, it's suppose we have one conductor, we have one motor, you know, this rotor is there, that is short circuited by end rings, and when we give supply to the stator, it produces a rotating magnetic field, okay, rotating magnetic field, because the coils are placed in 120 degree, so it 120 degree to each other, so it can produce a rotating magnetic field. And when this rotating magnetic field cuts this conductor bar, this magnetic field cuts this conductor bar, so there is another magnetic field create, and due to this an EMF is induced when this magnetic field cuts this conductor, and it's rotating in nature, an EMF is induced, and that EMF induces the current. And this is a closed loop because it is short circuited by the end rings, and due to this closed loop there is a current induced in a closed loop. Because it's closed loop, everything short circuited, and there is a current induced in a closed loop, and due to this an eddy current, there is a formation of the eddy current is also a loss. Eddy current is also a loss, which is not good. We have to minimize the eddy current loss, because if the eddy current loss is there, the efficiency of the motor transformer will reduce. So we have to minimize this eddy current loss. Basically core losses, core loss, you know, the transformer core loss, there is a two component, hysteresis loss and eddy current loss. Two component, I will deal later hysteresis loss, I will deal now eddy current loss. So eddy current loss is also if high, we have to reduce this one, because the efficiency of the transformer output by input, and input is the output plus losses, okay. So if losses will increase, the efficiency will decrease, so we have to minimize this losses also. So eddy current is a current that circulate in a closed loop within the conductor. So there is a closed loop and there is a induced current which are basically circulate in this closed loop, and due to this losses are increased, and we have to reduce this. How we can reduce this? Using a thin laminated sheet, because when you see this eddy current formula na, so it is directly proportional to T square, and T is the thickness of the T is the thickness of the core thickness of the conductor, okay. So we have to reduce this thickness also, so eddy current loss will reduce, okay. इसको let remove this, मैं इसको हटाता हूँ. Okay, so how we can reduce this? Remedies, what are the remedies? Using a thin laminated metal sheet, thin conductor, non-conductive coating, and material selection using high resistant material and minimize eddy current loss. So this is the eddy current, basically you understand very well. Now go to the further question. What is flame resistance, flame retardant, and armor cable? So flame resistance is the cable, this flame resistance is very important cable which is used for the emergency purpose, because let's suppose there is a fire in the vessel and everybody start trying to escape from the vessel, and there is a fire zone is there, and let's suppose if there is a conductor in the fire zone, and there is some emergency supplies which is connected like steering gear and all that connected with that supply, the cable which is coming from the fire zone, and it suppose the your cable is not fireproof. So what will happen? Your cable will burn or your cable will melt, and it will cut the power supply of the important emergency machineries, and your ship is in danger. Let's suppose you are in a very critical area, coastal areas, and suppose there is a fire, and when there is a fire and the cable which is coming from the fire zone and going to the emergency supply in the vessels, and there is due to the fire your cable is not fireproof, what will happen? This fire, due to the fire, your cable will burn and melt, and after that it can cut off the supply, and your all emergency machinery will not work, and now the ship will maybe go under collision and it will collide, and there is a various danger can occur due to this. So flame resistance cable basically which can support the which cannot support fire, it can prevent from the fire, and let's see. Flame resistance refer to the ability of a cable to prevent itself from the burning if when exposed to the extreme temperature. So let's suppose there is also one limitation, there is some temperature range is there, beyond this it will go, then there is a chances this cable will damage. Okay, so this cable should continue to operate normally up to the temperature of 3, let's suppose there is a fire, but the temperature is not that much sufficient, is less than 300 degrees Celsius, then this cable can operate normal. It will continue the supply to all the emergency sources, so the people can rectify the problem as soon as possible, people can escape from that place, people can overcome from the danger positions. So this cable will survive until that, and after that it will go for the damage. However, once exceed, it can only function as a limited amount of time. So after, if the temperature is increased, then it can work as for a limited amount of time. So the flame resistant, now you can understand it can prevent from the fire, but up to a certain range, and this is called as a fireproof cables, like used in the this emergency sources. Okay. So it is also known as the circuit integrity cable, allows energy to transfer through even case of the high temperature. Even there is a high temperature, it can allow the power to the flow. Okay, the sheath covering the fire resistant material are non-flammable. The sheath is non-flammable type and operate under the International Electrotechnical Convention. This is the standard, and it is the British standard. Okay, these are the some certain standard is there. There are so many standards. International, our Indian standard is what? IS. IS is our Indian standard. That basically tells us about the rules and regulation and technical standard, how the electrical installation will done, how the wiring will done. There are the certain rules and regulation which we have to follow for prevent any other hazard. Okay, so these are the various standards. Our Indian standard is IS. Okay, we are following IS standard in India. They are used in safety circuit, life support circuit, and other circuit which must function in the case of emergency. Okay, where we are using this fire resistant cable, we are using in the safety circuit, life support circuit, and other circuit which must function in the case of emergency. We are using in this critical areas and critical circuits, so it can does not support the fire, and it will continue to operate. And what is the flame retardant cable? This flame retardant cable. Okay, so I will tell you. The fire retardant refer to the ability of a cable to burn slowly, thereby preventing a fire from spreading throughout the property. It has the property of like burning, but it can burn slowly. It will burn, but it can burn very slowly, not frequently. It can burn slowly, and also prevent from a fire to spread out from a property. Let's suppose there is a fire in one compartment and cable is going from one compartment to another compartment. So if there is a flame retardant and cable retardant type cable, it will not supposed to spread the fire from one compartment to another compartment. Okay, it can prevent from spreading the fire from one compartment to another compartment, but having the ability to burn slowly. It can burn slowly. It can burn, but it can burn slowly. So there, but due to this, we are not using in the emergency circuits. This flame retardant cable are not using in the emergency circuit because it can burn slowly and it can discontinue the supply, and there may be chances of the danger. So flame retardant are the cable which can burn slowly and preventing a fire to spreading property. The flame retardant cable are designed to reduce combustion by lowering the heat emitted during the fire. What happened here? This flame retardant cable, this flame retardant are designed to reduce combustion by lowering the heat emitted during the fire. So how it can reduce this combustion? When this flame retardant cable are caught fire, that time a chlorine gas release, okay, a chlorine gas release which surrounds the cable, and it will not allow the oxygen to enter further inside the cable. So this way they can reduce the combustion and reduce the fire, and self extinguishing property is there. It can extinguish the fire. Even after that, let's suppose fire will stop, and it has self extinguishing property because the chlorine gas continuously release and it surrounds the cable, and so that it will no oxygen will enter inside the cable and extinguish the fire. Okay, this has a very special property of this cable. They do not allow power to transfer through it during a fire. But here I already told you, if there is a fire, it will not allow power to be transferred. The power will cut. And encased in gray and black outer sheath, the outer sheath of the cable is the gray or black color. They operate under IEC, International Electrical Code 60332, and British Standard Code. These are the standard code is there. Okay, the flame retardant cable have ability to self extinguish themselves when the origin of the fire is removed. I already told, if the fire is removed, it has self extinguishing properties. It can self extinguish themselves. Okay. So I already told you flame retardant and now flame resistance, so you can easily understand. And what is the armored cable? Armored cable are the electrical cables that include an additional layer of the protection of the metal armor. That is nothing but a metal protection is providing onto the cable that is protect from the mechanical damage and physical damage, which like let's suppose the cable is passing from somewhere and something fall down onto the cable, and if there is no armor protection is there, it will cut the cable very easily. But if there is a protection inside the armor protection inside the cable, there is a armor sheath is there, metal sheath is there, it can not cut the cable easily because due to the metal it can survive. Okay, so this is basically provide a additional layer onto the cable which provide safety from mechanical and physical damage like crushing and the rotor attack. So these are the basically all about the flame retardant, flame resistant, and flame armored cable. Okay, so I already talked about this. Now let's go to the question number 8, I think, no? Okay, let's see. Flame 7, yeah, this is a 7. Okay, so let's go question number 8. We'll see. This is a very important question because most of the time the surveyor will ask this question, so you have to go through this. Preparation of the electrical survey in the detail. Electrical survey. What are the electrical survey? Let's suppose their electrical survey basically happened when there is some construction and operation going on to the ship, and that time this class surveyor will come and check everything what are related to the electrical and technical, everything is complying with the international rule and regulation or not. If there is any deficiency, it will not issue a certificate, it will give a deficiency. You have to remove the deficiency. After that they will provide you a certificate, and it happens on every 4 year mostly. Okay, so electrical equipment inspected and tested during the complete engine survey. When there is a engine survey is there, then electrical survey is also there at a 4-year interval. It always happen at the 4-year interval. Such a survey is prescribed under the rule and regulation for the classification of a ship. It always follow all the rule and regulation. What are the survey items generally checked by the surveyors? The generators, motors, circuit breakers. Okay, they are checking all the circuit breakers are working properly or not. They are checking the generator, generator is working properly or not. Generator load voltage is everything okay or not. Generator is properly synchronized or not. Generator provide the output voltage. Generator give the efficiency, good efficiency or not, because load testing of the generator also happened. They check the governor performance, how is the governor is performing. They checked all the switchboard and fitting, main and emergency switchboard, distribution switchboard. They check all the bus bar cables behind the panel. They check all the bus bar and tightness of the bus bar, everything they checked during the survey. They are checked everything related to the switchboard, generator and governors. They check all the cables, basically insulations of the cable, insulations of the motor also they check everything. They will ask you the insulation resistance report. Okay, you are checking all the motors. When we are checking, give me the report of the mega report. Basically we are sending it the every 3 months. Okay, so these are the basically things. Okay, the insulation resistance I already told. They ask about the insulation resistance, motor and starters. They will perform some stop operation of the motors, and they can check the motor is working properly or not. There is no noise, vibrations and all. And then they check emergency power equipments also. They like, or they will check the emergency generator. They will test this load testing, on load test and off load test they will do. They will check the emergency generator, both method of starting, and they will check the steering gear also. The steering gear is working properly or not. The rudder is moving properly or not according to the steering gear command. They can check the rudder angle indicator is properly with the actual rudder position. They can check everything. Okay, so navigation light indicator, they can check the navigation light indicator is also working or not. There is no any duplicacies there. We cannot put any other thing in the navigation lighting indicator for the from survey. So if your vessel is UMS, they can further check more and more things, like the alarm associated with the main engine, all the alarm which is associated with the main engine, auxiliary engine. There are the various alarms is there, fuel oil leak alarm, jacket cooling water alarm, exhaust gas temperature over speed alarm is there, and your this low lube oil pressure alarm, differential pressure alarm, uske like turning gear rod engaged or not, start failure, control air failure, supply failure. There are the various type of alarm is there for the auxiliary engines. So they are basically checking all this alarm. They can test this alarm, and even maybe they will tell okay, let's check this auxiliary engine alarm, main engine alarm. So I will check everything is working properly or not. Okay, so electrical circuit from the various sensors such as the pressure stat, flow switch, level switch and temperature switch. So all the switches, basically the pressure switch, flow switch, level switch, electrical circuits which is related various sensors, they are checking these sensors also. And action of auto shutdown of main engine and auxiliary engine, auto starting up and standby unit tested. So basically they are testing all standby units also. Auto starting up emergency generator, they are doing this on load test also. I told you okay, they will put on the emergency generator on load and they will test it start or not. And they can do the auto starting also. Okay, they will reduce they will remove the main power supply, and after that it will check, it will start within the 45 seconds or not. like this by doing with the help of this test knob from the emergency generator room. Okay, so UMS requirement demand the standby main generator should be automatically started on the loss of duty of 45 seconds. So there is a requirement कि if there is a main power failure, emergency generator will come and load within the 45 seconds. So this is the rules and regulation, and they are checking all the bilge level alarms. They check all the bilge level alarms is working or not, fuel oil bilge alarms, their tank bilge level alarm, your cargo hold bilge level alarm. They can check everything. If they want, they can check everything. So main and standby electric power to overall alarms and monitoring inspected and tested. Complete inspection and test of fire detection. They are testing all the fire detection and alarm system. They can test the CO2 alarms also. They open the cabinet, and that time the ventilation and this all the dampers will shut down. So they can test this also. And main engine control will function correctly tested from the bridge position. They can test the main engine from the bridge position by giving the command from ECR to bridge or bridge to ECR. They can check this function also. Main control room and emergency position along the engine. And for tanker, there are the certain more like electrical equipment in the hazardous area surveyed every year during each docking survey and annual survey. I already talked about the Zener diode before. Zener diode is used in the hazardous area. So these are the electrical equipments which are in the hazardous area. They already check the hazardous area. Alternator survey is there. There are the various survey. I told you about the alternator. They check the alternator. They check the alternator each and every part, like this slip ring rotating diode is there, varistor is there, variable surge resistor is there, stator winding is there, rotor winding is there. They can check the insulation of the stator winding. They can check with the insulation winding of the exciter. How they are checking, how you can check, I already explained in my alternator section video. I already make one video in the generator. You can go through there. I will give the link in the description also. You can go through there and you can get a complete knowledge about the alternator, how the alternator is working, and how you can check the insulation resistance of the stator and exciter winding, how the voltage is produced in the alternator, why diode is fitted there, what the purpose of the diode, and what the purpose of this varistor, what is the purpose of surge suppressor is there, and how the voltage is produced, and if there is no voltage, what we have to do, how we can do the flashing, from where we can do the flashing, everything related to the alternator I already explained in my video. You go through the video and you can understand the alternator very easily. You go through my video just. Okay, so there is a alternator survey. What are the survey in the alternator? I already told. They check the stable operation. They will start the generator and run in the parallel, and they can check the parallel operation is correct or not, properly synchronized or not, there is a voltage frequency difference is there or not. Generator voltage on the wire, stator and rotor must be free of dust or not. Dust is a very important, you know. This dust is a very important, because if there is a dust, our efficiency and it can cause the resistance will increase, and there is a lot of things regarding the dust. So visual check on the deterioration, abrasion. They can check the bearing also. Pedestal bearing is the most important. You can tell the pedestal bearing is also damaged or not, and check the air gap between the stator and rotor must be 2 mm, like this gap is there. So the insulation test to the earth and between the stator phase winding, also air gap between the stator and rotor check to ensure the pedestal bearing are in good condition. Switchboard survey. Okay, there are the switchboard surveys there. I already told you what are the survey they are doing in the switchboard. They are doing the checking the cleanliness of the switchboard when all the generator is stopped and their prime mover locked. They just put all the generator to be stopped and prime mover locked up, so there is no chances of any movement. Now they can check internally and externally everything, like the main bus bar and their connection, tightness, bus bar supports, overheating sign at the connection junction, any overheating is there or not, and after that internal wiring is there, internal insulation resistance of the cable which is coming from the generator to the bus bar. They can check the insulation of that also. Okay, so cable entries at the switchboard bottom sealed with the non-flammable material. There is no flammable material is there. Earth bar is properly secured or not, hinged or not properly. Hinged panel door bonded with the earth is strapped to the main switchboard. Okay. Insulation resistance of each terminal measured, voltmeter, wattmeter, ammeter calibrated and tested. They ask for the calibration report also. They can check the voltage, wattmeter and ammeter calibration. They can check the earth fault also on the switchboard, earth fault is there or not, 440, 240, earth fault device is working properly or not, earth fault monitor is working properly or not. All the trip test, safety devices, synchronizing test, load sharing demonstration, earth lamp check. Okay, so these are the basically switchboard survey is there, and emergency power associated equipment, switchboard, ACB and AVR also they can test. Okay, they can test the AVR and this ACB also. And for emergency, they can start the emergency generator manually and automatically. Okay, by the two method, they want two method of starting. First is the battery operated and hydraulic start. If you don't know about this battery operated and hydraulically operated, how you can start the emergency generator in the hydraulic, and how you can start the emergency generator in this manual mode by battery operator, you can go through my video. I already made a practical video on the how to start the emergency generator by the two method. One is the battery start and another is the hydraulic start. You can go through the video also, and you can understand by clearly seeing the practical theory. I will not deal their theory. I will give you the practical view how you can do this. Okay. So they can check the electrical supply from the emergency switchboard, check for their proper voltage ampere. They can check the source supply connection also, ki is everything okay or not, breaker okay, everything is okay or not, this burst eye is working properly or not, the automatic mechanism is working properly or not, emergency lighting, fire pump and other related internal electrical interlocking arrangement. There is a interlocking between the main and emergency generator. Let's suppose your main breaker is okay, like main bus bar is supplying from the main switchboard and your ACB is that time close position, then that time you will not, there is an interlock, the emergency generator will not come onto the load until and unless there is a complete blackout and the main switchboard is properly isolated from the bus bar. Okay, they are not connected with the bus bar, that time only the emergency generator will come onto the load and supply to the power to the emergency bus. Okay, so there is a interlock is there, and emergency battery installation and its charging rectifier checked. They are checking the rectifier and battery installation, the properly the battery voltage and the battery voltage is properly battery charger is working or not, environment should be well dry, ventilated should be there, battery tops clean, electrolyte there is no spillage of the electrolyte, battery charging equipment working properly or not, battery locker, ventilation arrangement, they are checking everything. Okay, they are checking the earth fault also for the emergency 440 and 220 also, they are checking all this. And then they are checking the navigation. What they are checking, surveyor will ensure the navigation light indicator operates correctly and has the appropriate alarm. Broken wire and lamp can be simulated by a pulling appropriate fuse. They are checking by just removing the fuse and alarm will trigger or not. They are checking this one also. Okay. Power source for navigation light must be duplicated, usually alternate power supply being used from the emergency switchboard. They are checking any duplicacy of the power supply is there, because they are supplying with the emergency power board, and some people will do what, if there is no working of the emergency power, they can connect with the main power and do the duplicacy, so they can check this also, so you don't bypass this one. Changeover facility for power source to be checked. Changeover facility, there must be a changeover switch at the navigation, you can check this one also, this is the safety also. And although the actual lighting of the navigation is a part of safety equipment survey. So these are the basically things which are comes under the electrical survey. I already done everything regarding the electrical survey, you can just go through it. Okay, you can just go through it and read this properly. I already explained each and everything very clearly, I think. So hope it will work for you guys. And next question is our Solas regulation of the AVR. There is a Solas regulation of the AVR. There is a transient dip and steady state dip. Basically you have to understand these two concepts first. Okay, so I will tell you the Solas regulation then. What there is a transient dip. Okay, there is a transient, wait, okay, transient dip. Transient dip occur when there is a, let's suppose transient is sudden, you switch on some heavy power motor. Okay, then that time due to the heavy power, the inductive power, I told you about the reactive power will increase because the need of the magnetic field is increased, so the reactive power will increase, and due to this there is a sudden drop in the voltage from, let's suppose, 440 so let's suppose voltage will further drop to 420 volt, 415 volt, so drop in voltage. So it will drop for next 5 second or 10 second or 2 second, like this, 2 second, 5 second, 10 second, like this. So there is a certain drop in a voltage due to the switch on heavy power equipment. Okay, so when you switch on the heavy power equipment, there is a certain voltage dip, and this AVR will compensate the dip, and AVR must compensate this voltage dip. They can AVR, automatic voltage regulator. The main function of this AVR is to maintain a constant voltage. Suppose AVR is a device, our generator having a 440 voltage, so AVR, the main function of this, it always provide a 440 volt until and unless there is a change. It can compensate that change as soon as possible and maintain the voltage up to the 440 volt. Always maintain the constant voltage, maintain constant voltage. Okay, so always maintain a constant voltage. So the main purpose of this, and if there is a transient dip, AVR has to compensate that dip as soon as possible, and there is a transient, if there is a transient dip, if there is transient dip, it can survive up to plus minus 15% of error and recover within 1.5 second. Okay, so these are the one regulation, and for steady state dip I will talk about steady state, plus minus 2.5% of error within 1.5 second. Okay, for steady state. Okay, this is the steady. And what is the steady state dip? Due to the capacitive or inductive type load. When the load is of capacitive type and inductive type, and due to this capacitive and inductive behavior, there is a stored in energy, and due to this there is a drop in a voltage, and it will continue throughout the circuit. And when there is any machinery which is running continuously and there is a capacitive and inductive type of load, there is a drop in a voltage, and this voltage will continue till throughout the circuit is working. Okay, so there is a steady state dip, and that is regulated by the AVR, and AVR will recover that dip, and it can up to plus minus 2.5% of error and recover within 1.5 seconds. This is the basically AVR regulation. If let's suppose 2.5%, it means 440, you can convert into 2.5% of this, whatever the value will come, it can survive up to that value only. And for the transient dip, if there is a transient dip 440 volt, plus minus 15%, it can survive up to plus minus 15, but beyond this 15% there is a damage in the AVR. Okay, so it can survive up to 15%, and recovery to 440 volt within 1.5 seconds. So these are the AVR regulations. That is very important. You have to understand this one. Okay, and one more thing I will tell ki this will happen. Solas regulation. I will write everything. Wait, I can write. I will remove this all. I will remove this all. Okay, I will remove this. Okay, so now I will write this Solas regulation for you guys. Solas regulation. Okay, I think this tip is a little bit more. Okay, Solas regulation. Okay, so transient dip, you write down on your notes, up to plus minus 15% and recover within 1.5 second. Second is the steady state dip up to plus minus 2.5% and recover within 1.5 second. And but AVR is fitted onto that vessel which having AVR fitted must fitted, okay, must fitted onto that vessel which having engine power greater than 2250 kilowatt and piston diameter 300 mm. So these are the criteria. These are the criteria and these are the regulations. You must understand this Solas regulation of the AVR. So I already talked you about this. Okay, so you have to remember this one. So let's go to the further this normal transformer and welding transformer. This is the last question in our section. So I will take one more page for you guys. Okay. Oh, better I will remove this page. Okay, so I will take one page. Okay, this normal transformer and welding transformer. So first of all, you know what is the normal transformer. Okay, so I will tell you what is the normal transformer. I hope ki you will understand everything. Normal transformer. So what is a transformer? Okay, transformer basically is a device which transfer the power from one circuit to another circuit, and there is no variation in the frequency. Frequency is constant there. We are just transferring the power from one circuit to another circuit, and we can do the step up, step down voltage is there. It means we can increase the voltage, we can decrease the voltage, but the frequency is same. And this is a static device. Transformer is a static device. Transformer, static device. Transfer power from one circuit to another circuit. Okay, via primary and secondary winding. I will tell you about this secondary winding. Okay, primary winding is denoted by NP and NS, secondary. So we can transfer the power from one circuit to another circuit, and it is a static device. Why? Because frequency is not vary, frequency constant, and we can step up or step down the voltage, okay, by the help of number of turns. What is number of turns? We are doing the windings in the primary section and the secondary section. Let's suppose I will show you this transformer, okay. Here we are doing, let's suppose this primary source is there, okay, AC source. I take this AC source, that is, let's suppose 440 volt, okay, and here one load is there. Some circuit is connected with the transformer where we are taking the output from the secondary. This is the primary and this is the secondary of the transformer. And here this is the primary winding having some turns of the copper coil is there, are wounded on the primary side, and secondary side there is a basically core material is there. You see there is a core that is made up of ferrite, or iron, and we are doing this here. Windings is there, winding is there, okay, there is a winding. We are doing this winding this with n number of turns, that is primary, and n number of turns with the secondary, and based upon this winding that is wounded on this core, we are doing step up or step down, step up or step down, okay. We just transfer the power from here, we connect with this supply, and when we connect this supply, current flowing from the primary winding, and due to this current flow between the primary winding, there is a flux generation. And there is a flux generation which create a magnetic flux generation. It means there is a magnetic field, and due to the mutual inductance, you know the mutual inductance, when there is a current carrying conductor and the nearby another conductor is there, and the due to the self inductance, the magnetic field also created onto the nearby conductors. So that is the mutual inductance. So when we connect this conductor core with the power supply, that time due to this current flow between there, and that is the primary current, I denote with I1, and this due to the primary current there is a flux generation, okay, there is a flux generation which linked with the secondary circuit, because due to the mutual inductance the flux linked with the secondary circuit, and due to this flux link, that is the magnetic field which is rotating in nature, and due to the rotating nature, you know by the electromagnetic induction, when a current carrying coil varying in a magnetic field, it produces an EMF, rate of change of EMF is there. So due to this flux linkage in the secondary side, there is a induced EMF is there, that is denoted by E2, and here V1 is the your supply voltage, and that is the induced voltage, and due to this induced voltage the current is start flowing if you connect the load here. If you connect the load here onto the secondary side, there is another current will flow, that is the I2 onto the secondary side of the transformer when you connect with the load, okay. So these are the things. So here you know the power which is the primary P1 I1 equal to E2 I2, no change of power, power constant, same power same, okay. Same power is transferred from one circuit to another circuit. This is the basically power, P1 power, primary side power is equal to secondary side, primary side power primary equal to power secondary here in the normal transformer, okay. So these are the primary power equal to secondary power, and the here frequency is constant, and we are doing the step up and step down voltage. Now I will talk about the step up and step down voltage, so you can understand it various. And here you can see we are using the n number of turns, and here we are using n2 number of turns, and based upon the n1 and n2 we are step up or step down. What is step up, step down? Step up I will tell step up, let's suppose the primary voltage which is 440 volt, and you want to increase this voltage, no, let's suppose example is, I will give the primary voltage is 220 volt and you want your requirement is 440 volt. Okay, so your requirement is, let's suppose 440 volt secondary voltage, you want 440 volts. So you can convert this with the help of number of turns. We can just adjust the number of turn and we can increase the voltage from 220 volt to 440 volt by the difference in the number of turn. But how we can do like this? We have, in the case of step up, we have to increase the number of turns in the secondary side. We have to increase the number of turn in the secondary side, that is N2, that is N1, number of turns, okay, N2 turns. Okay, let's suppose I will give you one example. Here for step up, N2 is greater than N1, step up, that is step up. So you have to increase the number of turns. Let's suppose here you make 100 turns or 50 turns. Example I just gave, because the number of turns should be greater in secondary side. So you can step up this voltage. You can calculate this also by the help of the formula. I will just tell you the formula also. You can calculate this, how much turn is needed for making the voltage of the 440 in step up, step down voltage. So this I will remove. I hope you guys all understand very well. I will remove this all. Just clear your concept. If your concept will be clear, it is very easy to understand everything and you can understand it very easily. There is no any problem within there. So I can give you here. Okay. So this is the my N1 turn and this is N2 turns. I will note here turns. Okay. And here let's suppose step up, (220), any 440, like 3.3 kV, 6.6 kV, anything, whatever you want, you can step up here. Okay. So what we have to do? We have to increase the number of turns here. So N2 is greater than N1, then it is step up. Okay. And same thing I will do here. I will just copy this, paste this. Let's suppose here. So here, oh wait, here, oh, okay, step, so I will here step down now 24 volt. Let's suppose you want to convert from 220 to 24 volt. So what we have to do, we have to increase the N1. N1 is greater than N2. N1 is greater than N2, then your voltage is step down. In this case, what here is going here? So here is nothing. When you step down, there is step down, so voltage will reduce. But to maintain power, at secondary, you know, power at primary equal to power at secondary. Okay. So primary power equal to secondary power, primary power equal to secondary power. So V1 I1 equal to, okay, E1 I2. So here power is same. So for let's suppose here voltage is your V1 is 220 volt, and your this voltage is more and current will be, let's suppose, 5 amps. Okay, and E2 E1, this E1 is for the secondary. So here you reduce E1 up to the 24 volt. Okay, so here power have to always make constant. Then I2 what will happen, just check here, V1 into I1 you just do 220 into 5, 1100. Okay, this is the power for the primary side. So for secondary also the power should have to maintain same. So here 24 volt. So current will, you have to calculate the current also. So just here you calculate the current 1100. Okay, divided by 24 you have to do, that is of your I2. Okay, so once you calculate this current, you can know the current value will increase. Why current value will increase? Because you have to maintain this power. So current will increase up to mostly this pen battery low. Okay, this current will increase up to 45.8 ampere. So you see here the power will always constant, but our current will increase. So current will increase and heat will also increase. Heat will also increase, but power will always maintain. Okay, the primary power and secondary power always maintain, but current will increase. But let's suppose if you reduce the voltage, then current will increase, and if your voltage will increase, then current is reduced. So to maintain constant power. So this is the basically funda, you have to think about this, and basically only this principle we are using in the welding transformer. What we are doing in the welding transformer, I will just now explain with you the welding transformer. You already know how to step up or step down, and how to maintain the constant power, how you manage the constant power, because power is always same into the transformer, only we are doing the step up or step down. Step or step down, I just maintain here step up or step down. Step up, voltage increase, current decrease, power same. Okay, to maintain power same, but in step down voltage decrease, current increase to maintain same power. So basically this funda only we are doing in the welding transformer. Why we are using the step down in welding transformer? I will take one more page. Let's suppose why we are doing this in welding transformer. Now I will talk you about the welding transformer. This welding transformer. Now you can easily understand. Now you can very easily understand what is welding transformer. So welding transformer is just it is step down transformer. What is it? Is step down transformer. Why we are using this step down transformer? You see heat, you know heat is equal to I square R. If you want to melt a metal, you have to increase heat. Heat will increase, melting point of metal will increase. So heat will increase, melting point of metal will increase. But how you can increase the heat? Heat can only increase by the increase in current. So how you can increase the current? You can increase the current by the help of step down transformer. What we are doing here in the step down transformer, this is the step down transformer, you know, this is the step down, N1 is greater than N2. Here we less turns. Now you can talk, you can understand very well and you can tell very fast. Okay, so less turn, more turn. Here V1, let's suppose 20 to let's suppose 440 volt. V2 we are doing up to 60 to 70 volt. Okay, that is we are doing 60 to 70 volt. That is DC also, that is AC. Okay, we are doing DC also, welding transformer also DC, but we are doing here for rectifier, we are using rectifier, then we can convert this voltage. Okay, so this 60 to 70 volt AC we are taking here in the secondary side, and what we are doing here, we are doing less turn and here we are doing more turn. So now here what current will, I2 will increase and I1 is decrease to maintain P1 is equal to PS. Okay, power same, constant power. Now you can tell very easily, you see. So what we are doing here, we are just doing this, current will increase. Now by this combination we are using step down transformer. With the help of this we step down the voltage up to 60 or 70 volt AC, and there is a AC transformer, AC welding transformer also, and DC welding transformer. For the DC welding transformer we are using the rectifier circuit to convert the AC into the DC, because transformer always work on the AC, not on the DC. If you give the DC, it will short circuit because no magnetic field will variate. Some surveyor will ask you also why the transformer is not given the DC supply, because we need a rotating magnetic field for to induce the EMF. If there is no rotating magnetic field, it will not induce EMF. There is no power transfer between the circuit and it will act as a short circuit, and the transformer will burn. Okay, so this is also a condition. So we step down this transformer with the help of variation in the number of turn. We step down the voltage, then current will increase. If the current will increase, our heat will increase. If heat will increase, it will melt the metal very easily, and there is a return cable which can take the return path of the current and it can complete a circuit. So this is the basically step down transformer, basically uses in the welding transformer. So I explained you very well. So you can now check the welding transformer is a such kind of transformer which produces a large amps of the current in its output side, secondary side, and low voltage in the secondary. Okay, I already told voltage will be reduced and current will increase. A welding transformer is basically a step down transformer. The reason for this is high current is required for the arc to be generated at the welding, because heat P is equal to I square R, increase R, very low heat will be more and more to melt the metal. Okay, electrode resistance is also very less, so provide a short circuit path. So when there is electrode, you see a welder is welding, there is an electrode in their hand, and when they touch the electrode into the ship hulls or any grounding path is there, so it complete a metallic part is there. When they touch the electrode to the any metal part, it complete a circuit, then there is circuit will complete a short circuit part due to the very less resistance, because electrode having very less resistance, so current will flow very fast and it will complete the circuit. And there is, due to the increase in current, there is a too much heat generation, we can heat the metal, and when they touch the electrode to any metallic surface, heat will evolve there and it can melt the material very easily. Okay, circuit, so that due to the sort of high current occur and more heat energy dissipated. Welding transformer is basically AC and DC, AC secondary and DC secondary having output voltage in the range of 15 to 45 volt load condition, and no load condition 70 to 70. What is load condition, no load condition? Load condition is when we are using with some load, and without any load it will the voltage with, I already told, if load in increase voltage will reduce. So here no load voltage is 15 to 45 and load voltage is 15 to 45 volt and no load voltage is 70 to 75 volts. So I think I already discussed all the 10 questions. Maybe I don't know video will be long or not. I don't know about, but I explained you everything very clearly. So that's why, because let's suppose you see if video will go long, that doesn't matter. If you understand the concept very well, that the matter. If you understand the concept once, you never have to search anywhere, you never have to open any book and read again and again to understand the same concept. So you can follow my channel and you can just share this channel. I maybe part 2 will come soon. This is the part 1 of electrical, and after that next 10 question will come further soon, maybe tomorrow or day after tomorrow it will come. And there is a series of oral and written. I will just make videos as soon as possible for you guys, and it is totally free service. You guys just follow. If you like the video, if you just like my teaching, just comment on the pin section. Really, it's very motivated. People will motivate me, and it's very good for me to make and more videos. So hope so you can understand everything. So hope you guys do well. Just make a notes and start preparing as soon as for your orals and returns. So see you soon later. Okay, goodbye, take care, thank you.